Let's return to limits of rational functions, and let's look at the following example. I want us to find the limit as x goes to 1 of x cubed minus 1 over x minus 1. Now here, if I plug in 1 into my denominator, I'm going to get 0 in the denominator. So that means I can't just plug in my number into my function to compute this limit. So we're going to have to do something different here. So let's start. What we're going to do is we're going to factor the numerator. This is a difference of cubes, and so there's a formula to factor this. This factors into x minus 1, x squared plus x plus 1. And now if you notice that in the numerator and denominator, I have this x minus 1 and this x minus 1. So as long as x is not 1, I can cancel those values. So f of x would be, if I canceled those, it would be x squared plus x plus 1 as long as x is not equal to 1. And remember, when we're taking limits, we aren't thinking about x. X is not really allowed to be 1. We want near 1, not equal to 1. And so because of that, when I'm computing this limit, I can now, instead of working with this rational function, I can now take the limit after I've canceled of this polynomial. And that's great because this polynomial is much easier. If you have a polynomial, just plug in your number into your function to get your limit, and my limit is 3 here. So sometimes this technique is called the dividing out technique. The idea is you're canceling and reducing down your function, essentially. Let's look at one more of these. So find the limit as x goes to -3, x squared plus x minus 6 over x plus 3. So again, if you plug in -3 into the denominator here, you're going to get 0 in the denominator, which is bad. So what I'm going to do to compute this limit, we're going to factor the numerator, use our dividing out technique, and this will factor into x minus 2 and x plus 3. And now I can cancel these x plus 3's here and get the limit as x goes to -3 of x minus 2. And I have a polynomial now, so I can just plug in -3 minus 2 to get the limit of -5 here.